So we're going to pick up with this example here. And what we had done yesterday, no, that was Monday, that other day, whatever day that was, is we had identified that we've got 15 grams of chromium, and they're asking us how many grams of chromium oxide. So we read through the whole question, and we identified what we were given, and we wrote that under the equation and what we're trying to find. And then the path for these types of problems is grams to moles to grams. I'm trying to do something and it's not very good. Grams of what? Well, grams of the thing that they gave you some information about. So grams of chromium, and then we're going to convert that to moles of chromium. To convert between grams and moles, we use the molar mass. We learned how to do that in Chapter 8. And then this balanced chemical equation tells us, oh wait, that's not balanced. We had balanced it, and now it's unbalanced because we're starting over again. Yeah, this was a 4. And this was a 3. There we go. So the equation tells us 4 atoms of chromium would produce 2 molecules of chromium-3 oxide, or 4 moles of chromium would produce 2 moles of chromium oxide. And that's what's important for being able to convert from moles of chromium to moles of what they're asking us for. It's not, I didn't leave enough room. Cr2O3. And then to grams of Cr2O3. Understanding this path is really important. This is our roadmap that tells us where to go. You know, it's Dora asking the map, how do I get to the snowy mountains? I don't know why I'm always going to the snowy mountains. They're actually snowy now, which is great. So in our path, the first step is grams to moles. We're changing the unit. We're not changing the substance, though, because we can't change 2 things at once. You can only change 1 thing at a time. So we're going from grams of chromium to moles of chromium, and that's the molar mass. We get that off the periodic table. Here, the unit is staying the same, but the substance is changing. So moles of chromium to moles of chromium oxide. That relationship comes from the balanced chemical equation. It's these coefficients. And then from moles of chromium oxide to grams of chromium oxide, the compound is staying the same, the unit is changing, and this is the molar mass. So with our path, we can just start writing our equation. 15.0 grams of chromium. The units in the path are the units that go on the tops of all of our fractions. There are 3 arrows. We're going to have 3 fractions. Grams of chromium to moles of chromium to moles of chromium oxide. And yes, it's a little tedious writing out all the formulas. Just do it. Getting the answer wrong and starting over again is pretty tedious too. So the path gets repeated here. Grams of chromium to moles of chromium to moles of chromium oxide to grams of chromium oxide. And then we're just following our pattern of dimensional analysis and putting units in the bottom to cancel out the unit in the top of the previous term. So we want these to go away. Any questions? We get all our units in, and then we need numbers. The one in the middle is the easiest, moles of something to moles of the other thing. We just go look at the equation. Here we've got Cr2O3 in the numerator, and so we find it in the equation, and we look what number is in front of it. Oh, it's a 2. I'm going to take that 2, and I'm going to write it here. 2 moles. And we look at the chromium. In front of chromium is a 4. So in the equation, the math equation down here in front of chromium, I'm going to write a 4. That's all it is. The number from the balanced equation. The first term and the last term are molar masses. When you're doing this molar mass, you do not look at these coefficients. Sometimes students will say, well, yeah, but it's 4 chromium, so I need to multiply this by 4. No, you don't. We want to know the mass of 1 mole of chromium. The 4 does come into the equation, but it comes in the middle term. The coefficients only show up in the mole ratio. The coefficients do not show up in the molar masses. So what's the molar mass of chromium? 52. There's no calculating there because it's an element. 52.00. And then we need the molar mass of chromium oxide. And so that's 2. I'll get to that. Thank you. Hold that thought. 2 times 52 plus 3 times 16. And what does that equal? Oh, okay. 152. That sounds right. Bless you. So in this last term, again, we're finding the mass of 1 mole. That's what molar mass is. And it's the number of grams in 1 mole. Bless you again. Bless you all day. Pollen count is very high, is what the sign says. And from the sneezing everywhere, I believe it. Okay, so then we calculate 15 times 1 divided by 52 times 2 divided by 4 times 152 divided by 1 equals. And how many significant figures should we put in our answer? We started with 3. So that's the smallest. So we should round our answer to 3. So I'm going to write 21.9. And the unit is grams of chromium oxide. Yes?
Just write it without the bottom part, because it cancels out anyway.
Can we write it without the bottom part? You mean these down here?
And just multiply it by the top ones, like 15 times 1 times 2 divided by 152, or am I understanding?
There may be some situations where if you didn't put the denominators in there, it might work out, but that's a very dangerous thing because most of the time it's not going to work. Yeah, most of the time it's not going to work.
Because with the previous calculations we did a few days ago, I noticed that it didn't really matter if you solved the bottom because you would just cancel it out.
There are some things where that does happen. When we do stoichiometry, though, we're going to end up with a molar mass in the denominator and a molar mass in the numerator, and they're most likely going to be different. The mole ratio here, I mean, that does simplify to 1/2, which you could certainly do in your head, but it doesn't really save you anything. And
To establish a method and
I think, yeah, so what I am trying to do is show you a pattern that you can apply to everything. There are definitely different ways to do these problems correctly. You can do them in individual steps. You can first calculate the moles of chromium and write down the answer. And then you can calculate the moles of the product and write down the answer. And then you can calculate the grams of the product and write down the answer. I think that's a little more involved.
this whole thing just threw me off.
Okay.
What do you want us to do? Multiply 15 times 52 and then times 2 and then...
But it's multiplied by 152. So multiplying by 152 and dividing by 52, that doesn't cancel out.
Oh, so it's zigzag.
Yeah, when I put this in my calculator, it's 15 times 1 divided by 52 times 2 divided by 4 times 152 divided by 1. And I think when you get a pattern and make a habit and just go straight across, then you don't end up missing any numbers. And this is the same idea that we did when we were converting units, like inches to, micrometers or something. You say, oh, well, I can go from here to here, and from here to here, and here to here. And then you just string them all together, making sure that your units cancel out. And so we don't have to remember, am I supposed to divide by the molar mass to get the moles, or am I supposed to multiply? You look at the units, put the units in, and then put the number with the correct unit, and then it kind of figures itself out. And then you just follow, multiply by the top, divide by the bottom.
What threw me off was this zigzag.
The zigzag,
Multiplying and dividing.
yeah. Any other questions? Yes?
I don't see where you're getting, where you go from grams to moles and from the moles of it on. Where does it say that that's what we're supposed to be? Follow that pattern.
Why are we going grams to moles to grams? Right? Okay, so it's asking us, it's telling us we've got 15 grams of chromium, and they're asking how many grams of this would be produced. Do we know the relationship between grams of chromium and grams of chromium oxide? No, we don't. And we really can't even go look it up, because that's going to be different for every equation. And there's a relationship between chromium and chromium oxide. There's a relationship between chromium and oxygen. There's a relationship between oxygen and chromium oxide. So there's 3 relationships in this very simple equation. And so the way we calculate this is what the what the chemical equation is telling us is how these relate to each other in terms of numbers of particles, of atoms and molecules. There are 4 of these needed to make 2 of these guys. Well, that's great, but that's in terms of particles. But we're measuring things in terms of mass. And so we need to convert the mass to a number that's related to number of particles. We don't actually go to number of atoms, but we go to moles, which is a counting number. So it's like with donuts, we're not counting individual donuts, we're counting dozens of donuts. So we're using the mass to count the atoms. And the equation gives us the relationship between the numbers of particles. So this part in the middle is looking at the relationship between the number of these particles and the number of those particles. And the part at the beginning and at the end is really just practical. There's really no shorter way to do this. This is the most straightforward way, and it's the fastest, because it works for everything. And so you learn one method and you can use it on any equation.
That was gonna be my next question. So no matter what the problem is, it's always going to be.
Grams to moles to moles to grams. If you're given a mass and they ask you for a mass, it's always grams to moles to moles to grams. Grams of what they give you, to moles of what they give you, to moles of what you want, to grams of what you want. Always the same. Okay? Any other questions? Because this is an important topic, and so it's important that you understand what we're doing. We're going to do another example. Tin 2 fluoride is added to some dental products to help prevent cavities. Did you know there was tin in your toothpaste? Tin 2 fluoride is made according to the following equation. So solid tin is reacted with hydrofluoric acid, and that forms tin 2 fluoride and hydrogen gas. How many grams of tin 2 fluoride can be made from 55 grams of hydrogen fluoride if there's plenty of tin available? Always read all the way through the question before you start writing stuff down. So we read the question. The question is asking how many grams of tin fluoride. So I'm going to put a question mark here, grams. That's what I'm trying to find. The number they're giving me is 55 grams of hydrogen fluoride. So 55.0 grams of HF. So this is what I'm starting with, and this is what I'm going to. So grams to moles to moles to grams. Well, grams of what? What am I starting with? What did they give me a number for? The HF. Grams of HF to moles of that same thing. And then here's the transition where we go from one thing to another. They're asking about the tin fluoride, so we're going to go to moles of SnF2 and then to grams of SnF2. So it's the same idea, we're just applying it to a different chemical reaction. And you can do this between any two substances in the equation. This equation has four things, 2 reactants and 2 products. You can do this between 2 products. You can do it between 2 reactants. Here we're starting with a reactant and finding a product. You could also have a number for the product and find one of the reactants. You can do any combination, grams to moles to moles to grams. Any questions about the path? Because if we don't get how to make the path, it's just hopeless. That's the key, right? Everybody okay with my path? Once we have the path, we just follow it. Grams of HF. Well, we're told that it's 55 grams of HF. And then there are 3 arrows. We're going to have 3 fractions. And then you take the units from your path and you write them in the numerator. So moles of HF and moles of SnF2, didn't leave enough space, and grams of SnF2. This unit is here, this unit is here, this one is here, that one is over here. It tells you what to do. We want to get rid of this unit, and so we're going to put it down here and divide by it. Wait, I zoomed in too far. I can't see where I was. I want it over here. Because I want these units to cancel out. These calculations here are the biggest reason why I really tried to force dimensional analysis down your throat in the second chapter. Because some of you can do the other unit conversions just by understanding the units, but then you get to this stuff and it's like, oh, this is hard to visualize. But if we learn the pattern, we can just follow it. So now we need to get rid of this unit, so we're going to divide by it. Moles of HF. They cancel out. Because mole HF divided by mole HF is 1, and that doesn't change the value. And then here we're going to divide by mole of SnF2. So those cancel out. Get all the units in place and then put the numbers in. The middle term, mole to mole, this is a mole ratio. This is the easiest one. No calculation involved. SnF2, what number is in front of that in our equation? It's an implied 1. It's not written, but it's implied. And what's in front of the HF? A 2. So I'm going to write a 2 in here. So in this center term, it's coefficients from the balanced chemical equation. Now set the balanced chemical equation aside in your mind and don't go back to it. You're done with it. Now we need molar masses. The relationship between moles of HF and grams of HF is called the molar mass. The mass of 1 mole of HF equals the mass of 1 mole of hydrogen plus the mass of 1 mole of fluorine. We learned how to do that. So hydrogen is 1.008 and fluorine is 19. And we add those up and we get 20.008. And that's 20 grams of HF is equal to 1 mole of HF. I don't always write the units out there. but that's what they are. So 20 grams. So the 20 goes with grams. Don't put it with the moles. 20.008. And then we need this molar mass here. I've run out of room at the bottom, so I'm going to move up to the top. Tin, 118.7. 118.7 for tin, and 2 fluorines. That's 19. $156.7. And I would encourage you to write this out. If you get mixed up with units, go ahead and write the units on it, but at least just write out what you multiplied so that if you end up getting the wrong answer, you can go back and find where you made your mistake instead of just starting over again. So that's the number of grams in 1 mole of SNF2. 156.7. I consider this equation down here, as I have written it, to be the minimum that you should write down in showing your work, and you should always show your work. So that's the minimum. And so now we just get out the calculator. 55, I didn't write a number in there, but what would the number be right here? It would be a 1. If you multiply by 1, it doesn't matter. So 55 times 1 divided by 20.008, just going straight across, times 1 divided by 2 times 156.7 divided by 1 equals, and again we were starting out with 3 significant figures, so I'm going to report my answer as 215, and the unit that isn't crossed off is grams of SNF2. Any questions? Anytime you calculate something, especially with that many numbers, run it through twice on your calculator because it's so easy to make a little mistake. It's a shame to have gone through all that work, set it up correctly, you understand what you're doing, and then because when you pressed a 2 on your calculator, it didn't actually get pressed hard enough, you end up with the wrong answer on a test. That's just messed up, right? So any questions about this example? Here's another one. Consider the following reaction. PCl3 plus 3H2O goes to H3PO3 plus 3HCl. What mass of H2O is needed to completely react with 20.0 grams of PCl3? This is more of a scaled down, bare bones question. They don't give you any background information, just giving you the bare essentials. So I read through the problem, and now I'm going to look through it again and make some notes. If you're doing a homework problem like this, you should take this equation and write it down on your paper so that you can use it to organize the information. What mass of H2O? That's the question. So under H2O, I'm going to write question mark. What mass? What unit do we use for mass? We use grams, right? Not moles or meters or anything like that. 20 grams of PCl3. So under PCl3, I'm going to write 20.0 grams. Now here, they've given me a mass of one reactant, and they're asking me a mass of another reactant. That's different than the last one. Why might you ask a question like this? Well, you've got 20 grams of PCl3, and you want to make sure that you put enough water in there so that it can completely react. How much water do you need? Well, we can calculate it. So the path is what? grams to moles to moles to grams. Okay, so grams to moles to moles to grams. Grams of what? Grams of the thing they give you the number for. PCl3. And we're going to convert that to moles of the same thing. Moles of PCl3. Because we can do that with the molar mass. We're doing the path this way, I just realized, because we have conversion factors available for these steps. Like going across a river, you know, if the river's too wide, you can't just jump across it. You have to take the stepping stones that are available. You're like, well, but I want to just do one stepping stone and get across. But there's no stepping stone that you can reach, so you have to go through this other way. This is the path. This is how the river is. Where was I? Okay, so moles of PCl3 to moles of the thing we're trying to find. Don't go off and include any of these guys. We're just focusing on these two. The one that they give us information about, and then the one that they're asking us about. So this is moles of H2O, and then we're going to go to grams of that. This is what they gave us, 20 grams, and this is their question. What mass of H2O? So then we just start 20.0 grams of phosphorus trichloride times. Zooming in farther and farther each time, the lines are getting smaller. Grams to moles to moles to grams. That's what goes on the top here. Just copy it down. Grams of PCl3 to moles of PCl3 to moles of H2O to grams of H2O. No caller ID. Just going to voicemail. So then this unit comes down here, so that that'll cancel out. Like that. And this unit comes down. Are you seeing the pattern here? The formulas of the compounds and the numbers that we put in here change from problem to problem, but the overall pattern is the same. It's like a fill-in-the-blank sort of a thing. I like to do the middle one first because it's easy. Why not get the easy thing done first? These numbers, moles to moles, come from this equation. In front of the PCl3 is the number 1. It's not written, it's implied. So down here I'm going to write the number 1. If you prefer to leave that implied as well, it's fine. Won't change anything. In front of the H2O is the number 3. So here we put the number 3 in front of the H2O. The first term and the last term will be the molar masses. So PCl3 has 1 phosphorus and 3 chlorines. So 30.97 plus 3 times 35.45. If you're still a little rusty on calculating molar masses, you need to work on that because it's going to make this part really hard. So that's 137.32. So 137.32 grams of phosphorus trichloride, I want that to look like a decimal point, is equal to 1 mole. And then for water, we've got 2 times the mass of hydrogen plus 1 oxygen, and we get 18.016. 18.016. Any questions? Now we just calculate 20 times 1 divided by 137.32 times 3 divided by 1 times 18.016 divided by 1 equals, and with 3 sig figs this is 7.87 grams of H2O. Any questions? Is it making sense? The thing is, students tell me this all the time, it often looks easy when I do it, because it is easy for me, right? I've been doing this for longer than I care to admit. When you try to do it yourself at home, it may be more challenging, but don't give up, okay? Don't give up. So if you're at home trying to do your homework, and the only way that you're going to be able to do this is if you practice it a little bit. You can't just watch someone else play baseball and then get up and hit a home run. It's not going to happen. You have to practice, right? If you're home practicing and you're trying to do one of the homework problems and you're just getting really lost, what can you do? Well, I would encourage you to go to YouTube and find this lecture and pull it up and pull up this example or one of the previous 2 examples and let it get started and then pause it and try to stay a step ahead of me. And that way, you're not sure what to do, advance it a little bit. Okay. And then maybe that was the little piece you were missing. But that way you can go step by step through these examples, thinking about it and doing it in your own time. Okay? You really need to get to the point where you can do a problem like this with just your calculator and a periodic table. Okay, you shouldn't need anything else.